Hello and welcome everyone. In this DSA Made easy video, we are going to be learning with respect to day A topic why and what is recursion. This is the first uh, new topic that we are beginning after the introduction to DSA, which we had spent 7 days, and now this topic is about recursion and backtracking, and this is the first topic in it. Why and what is recursion is what we will cover today. So, recursion is a function which calls itself directly or indirectly to solve smaller subproblems until it reaches a base case. Like, for example, let's say we want to calculate a factorial of a number, right? Let's say we want to, so it will be like n into n minus 1 into n minus 2 and so on till it reaches 1. So factorial of 1 factorial is always 1. That is something that we should know, and 0 factorial is also 1. So with these two base cases being known, we can perform these are the base cases, and these are the smaller recursive calls until we reach a base case, right? So the bigger factorial of n minus 1 is slowly divided into till we get a base case. So that's factorial and how we use recursion here. So I'll just write a small code snippet of how we are going to solve this in, let's say, uh, JavaScript. Let's say fact of n. Let's say this is a function. We check if n is equals to 1, then we return 1. This is the base case. Else we n into factorial of n minus 1. So here you see this recursive call to the same function. So this is recursion and this is the base case. And this is base case. So how it works behind the scene is, let's say we call factorial of so first we in step 1 we call it 4 into factorial of 3, and in step 2 4 into 3 into factorial of 2, and similarly we keep going till we reach a base case, that is factorial of 1. We know that factorial of 1 is 1. So here now we uh, now we compute it backwards, like 1 into 2 into 3 into 4. So this way the call stack. So there is something called call stack which uh, keep tracks of all these recursive calls, and once we reach base case and all these call stacks mounts back to the respective function value with return statement, and then we get the final required output with the recursive function that we have initially invoked, right? So there can be many examples for recursion. We can have binary search also done with recursion, Fibonacci series, like we calculate, we add f of n minus 1 plus n minus 2, so that is a Fibonacci problem. So there are some problems like tree traversal or uh, graph traversal also that we can do with recursion, right? So one of the advantages that we get with recursion is it is much cleaner when compared to iteration. Like for example, if we need to iterate the same code, if we need to perform iteration for the same piece of code, so we can do it this way. Like let's say for let I is equals to 1 to n, and we can say 1 into result. Let's keep result initially at 1, and finally we return result. So this would be the for loop implementation for factorial. But ideally, in larger problems, this would be much harder way to implement, in harder and much more difficult to understand with iterative approach. But factorial approach makes it a lot more easier to understand and implement quickly, right? So that's the reason that we have recursion in many different topics, and we will be seeing in many other sections as well, like in trees or linked lists or stacks also we might see it, right? So as I said, stack keeps track of all the smaller recursive calls, and once we reach the base call, then the stack computes the base call and also the previous recursive calls that were invoked. And as I said, iterative approach is uh, would be little harder to read and also quickly put it in terms of code, while recursive implementation would be easier to implement and also much easier to read also, right? So that's about it. So recursion is nothing but a function calling itself, and it solves in, the recursive call makes the bigger function split up into smaller cases like this, and once we reach a base case, then all the smaller sub problems get computed. Eventually the bigger problem also is solved with all these computations. That's about recursion. Hope you found this introductory video helpful. Please do like and subscribe to my channel. Thank you.